notations. We have different notations of giving a number set that I'm working with in mathematics. The first notation is I can use interval notation. The second one is Setbuilder notation, or I can draw a number set on a number line. The reason, or the places where we use this, the reason why I need to do this is if I'm working with data, it's sometimes necessary to just specify with the set of numbers you are working with. Say for instance, I'm doing an experiment where I'm throwing dice. Then I will specify the numbers that I use for my experiment, or specifically numbers between 1 and 6. 1 and 6 are both included in this set. And I'm working specifically with natural numbers, because I can't have a number bigger than 6 on a on a dice, or I can't have a number smaller than 1, and I also can't have decimal numbers. I have specific natural numbers, or whatever I'm working with. If I'm doing an experiment, sometimes I have to just identify what numbers I work with. And then also, if I draw a graph on the, you have heard of the range and the definition, the domain and the range before. Sometimes I have to specify this graph is specifically for the x values between 0 and 2, etc. And there I use, you can either write your answer in your set that you give in interval notation, Setbuilder notation, or a number line. Number line is not as acceptable always in grade 11 and 12 maths if you're writing a domain and a range, but you must know how to use these different notations. Right now, this is basically, think of this as 3 languages where I say the same thing. Say for instance, the word cat. In English, I use the word cat. In Afrikaans, I use the word kat. And I think in German, they use the word Katze, which is the same thing, just in 3 different languages. So this is also, I can specify the same set of numbers in 3 different ways. And it's not going to change the identity of the set of numbers. It's just 3 different ways of giving the 3 different things, right? So interval notation is something that typically looks like this, from 3 to 6, with 3 included, 6 excluded, a real number. I'm just giving you an example. I'm going to explain now how each of these work, and then I would say numbers between, say for instance, 3 and 6, where x is real numbers, in Setbuilder notation. This is the same thing, just in another notation. And on a number line, I'm going to draw between 3 and 6. I draw 3 is part of the set, 6 not. And I draw a line to show all of the numbers between 3 and 6. So I'm going to show you now how to do all of this, but this is how they look like. This is how interval notation look like. This is what Setbuilder notation looks like. And this is what a number line looks like. Alright, so let's quickly look at this. There's 3 things you need to consider when writing a set down in any one of these notations. You're working with a set of numbers, right? The first thing you need to consider, the endpoints of these numbers. Are they included or are they excluded? In each of these you need to consider that. And the second thing you need to consider is what number system specifically I'm working with. Am I working with real numbers? Am I working with natural numbers? Am I working with integers, etc.? And the third thing you have to consider is, does my set have infinite endpoints? So if I have, say for instance, numbers between 3 and 10, then I will see, is the 3 included, is the 10 included, or excluded. Say for instance I have numbers smaller than 3, then I still have to see whether the 3 is included or excluded, but then smaller than 3 will include an infinite set to negative infinity. If I have numbers bigger than 3, then I will have 3. I must still consider whether that's included or excluded in the set, but then I have also an infinite set that goes to infinity, because anything bigger than 3 stretches to the infinite. Alright, so those are the things I need to consider, and here is how I show them in all of the different sets. So say for instance I work with interval notation. That's the notation where I work with the brackets. The brackets around the numbers tells me whether these things are included or excluded. For included, I make block brackets around the numbers. So if this number is included, I make a block number. If the second number is included, not a block number, a block bracket. And if it's excluded, then I make round brackets. You can have a block and a round bracket, or a round and a block bracket, but the number specifically that you include, you make around that number a block bracket, and the number you exclude, you make a round bracket. So say for instance I'm working with a set of numbers between 2 and 5, and this is all of the numbers between 2 and 5 where 2 is included and 5 is not included in the set. So it's from 2 everything up until 5, like 4.99999 is included but 5 not. Then I will include 2 like this, and I will exclude 5 like that. In Setbuilder notation, that works with the smaller than, bigger than signs, and very simple. Included, I will make it smaller or equal to, then I include, or bigger or equal to, and I exclude a number by just saying it's bigger or smaller than. So if I say something is bigger or equal to 2, I'm just going to write the set here first. If I say x is bigger or equal to 2, that means I include 2 in the set. And if I say x is just smaller than 5, then I exclude 5 from the set. So that's how I show excluded, included in Setbuilder notation. And Setbuilder notation always has this x with a semicolon there, which just means x such that x lies between these numbers. So this just means x such that, or x defined as. It just says that where does this x come from? I'm working with my number set in terms of x. That's what that means. And I always put curly brackets around my Setbuilder notation to just include the whole set like that. And then I must now also say something there. I'm coming to that now in the next one. And then on a number line, to show included or excluded, what I will do is numbers from 2 to 5. It doesn't really matter whether you put the numbers on top or on bottom, and the dots on top or bottom. It doesn't really matter as long as you can just see what's going on there. To show a number is included, I make a closed dot. And to show that a number is excluded, I make an open dot. So in this set, 2 is part of the set, so at 2 I will make a closed dot, and at 5 I will make an open dot, and then I just connect that set. I connect it with a straight line for real numbers, but I'm coming to the number systems now. Alright, let's say this is real numbers, and then I'm just going to use real numbers there for all of these. Right, now let's look at the number systems. Here in Setbuilder notation, the number system I'm working with, I just specify there with a x and a little e like that, which means x is an element of this number system. And then if you work with real numbers, you put an r. If you work with integers, you put the z with 2 lines, etc. Let me just take that off there because it's a whole mess now. Right, so For Setbuilder notation, I will write x is an element of, and then I can either write real numbers or the natural numbers or the integers, whatever the case may be, what my x is a set of. In the number system, for real numbers, I draw a line between the dots like that, or rational numbers, but you will usually work with rational, natural, or integers in this case. And for loose numbers, like with loose numbers I mean separate numbers, like 1, 2, 3, 4, which is natural numbers, or the integers, which is -1, 0, 1. For separate numbers like the natural numbers and the integers and things like that, I will use dots. So if this set was natural numbers and not real numbers, I assumed it was real numbers here, but if this was natural numbers, I will go and make extra lines there for 2, 3, 4 and 5, and then I will go make separate dots to show that I'm not working with all of the numbers from 2 to 5, I'm working with the specific loose numbers. That's how you show the type of number system I'm working with on a number line. If it's loose numbers, you make dots. If it's all of the numbers included from one point to other, you just make a line. Alright, and for interval notation, it's actually quite simple. The interval notation is always real numbers. Right, always real numbers. So if something stands like this in interval notation, you assume I'm working with a set of real numbers. If you have a set that's not real numbers and they ask you to write that in interval notation, they will probably not do that. But if they ask you to write it in interval notation, you can't write a set that's not real numbers in interval notation. So then you just say something like this can't happen, or this is not going to happen. Interval notation must always have real numbers. If a set is given in interval notation, you assume it's real numbers. If you have a set of real numbers that you want to write in one of the notations, you can write it in interval notation. If it's not a set of real numbers, then you have to use Setbuilder or Numberline notation. You can't write it in interval notation if it's not real numbers, because interval notation is real numbers always. Right, so also that's why I assumed I'm working with real numbers, because it comes from interval notation. Alright, let's just create quickly one, because there I have now an example with real numbers. I just want to create one example, say for instance x, such that x lies between 2 and 5. Same example there. 2 is included, 5 is excluded, and then x is an element of the natural numbers. What will happen on my line graph is I have between 2 and 5. The three things I consider is my endpoints included or excluded, and I can just go and see there my 2 is included and my 5 is excluded. The second thing I consider is what type of number system I'm working with. I'm working with natural numbers here, so then natural numbers on the number line I show by making separate dots. And then the third thing I consider, am I working with an infinite set? But because I have endpoints at the bottom and the top, this is not an infinite set, so I'm done, and this is what I do. Right, so let's quickly just talk about infinite sets. Right, infinite sets works as follow. That is now, for instance, say I don't have that x lies between 2 and 5, but say for instance x is smaller than 5, or say for instance, this is one example I'm going to do, and I'm going to use real numbers here because I also want to show you the interval notation, and I can't do that if I don't have real numbers. Or say for instance x is bigger than -2, bigger or equal to -2. Right, this is now 2 examples. Let's do example 1 and example 2 rather, so you don't think that's one set. Right, in set builder notation, this will look like this. I have a bracket x such that x is bigger than 5. I think I now wrote smaller than 5 before. And I'm going to use real numbers so that I can also write it in interval notation. Or another example is x such that x is smaller or equal to, let's make it -3. And I'm going to again use real numbers because I want to just write it in interval notation also. Now, to show x is bigger than 5 in interval notation, quickly think if here is 5 on a number line, if 5 is there, all the numbers bigger than 5 will lie to this side, right, which goes to infinity. Just know the difference, this side is infinity and that side is -infinity. So if I use all the numbers bigger than 5, then my set goes from 5 to infinity. And then I just go and see is 5 included or excluded. It's excluded. And do I exclude or include infinity? Here is something you can remember for infinite sets, is infinity you can't include ever. You can't contain infinity. It's beyond anything you can contain. So I will always use round brackets again next to infinity and also next to -infinity. So in interval notation, this set will look like this, and this set is smaller or equal to -3. So I'm starting, the set lies between -3 and -infinity. Because it's all the numbers smaller to, here is -3, and it's all the numbers smaller which goes to -infinity and equal to -3. So now I go from -infinity, I always go from left to right, from -infinity up until -3. So the set will look like this, from -infinity up until -3. And then -infinity I can't include, and I just go and see -3 is included in the set, so I make a block bracket around that. Right, now I've handled my included, excluded. The number system in interval notation is always real. I just check, yep, I'm working with real numbers, and this is how I then treat infinite sets. Infinite sets specifically happens when you don't have two limits of numbers like that. It happens when you just have one limit and it goes to infinity, or one limit and it goes to -infinity. Alright, and on the number line, what I would do is I would just make an arrow like this. So say for instance I take all the numbers bigger than 5. 5 is excluded, so I make an open dot on 5, and then bigger than 5 lies to this side, and I'm working with real numbers, so I'm making a line and I just make an arrow to show that it continues to that side. Line is because it's real numbers, the arrow is because it's infinite to that side, and the open dot is because 5 is not included in the set. For this second example, if I have to go and draw that on a number line, my limit that I know is -3, so I'm going to put -3 on the number line. The -3 is included, so I make a closed dot, and then it's all the numbers smaller, so to this side of -3, and then I just make a line to that side and I make an arrow. Alright, the arrow shows it goes on, and now hopefully you can also see with this and with this, if the arrow goes to this side, I go to infinity, and then 5 is my, just compare this, 5 is my bottom limit and I go to infinity. If the numbers goes to that side, -3, can you see is on this side, it's my top limit, and it comes from -infinity up until -3. Alright, I just want to show you infinite sets with, because this is real numbers which has the line. I just want to quickly show you an example of infinite numbers where I don't have real numbers, infinite sets where it's not a real number, which means I can't now go and put this in interval notation, but I'm just going to do between Setbuilder notation and the number line, just so you can see what happens on the number line if I have infinite sets. Alright, so say for instance I have all the numbers bigger than 2, let's make it bigger than -2, all the numbers bigger than -2 that I have to go and write on a set. Right, so for Setbuilder notation, I must just specify all the integers bigger than 2. Alright, so just keep in mind all the integers bigger than 2. Then for Setbuilder notation, I'm going to write x such that x is bigger than 2, and if it said bigger or equal to, then I would include 2, but because it says specifically bigger than -2, sorry, I just go and write x is bigger than -2, no equal sign, and then this is now working with integers, so I put x is an element of the integers and I put the z there with a double line. Alright, now on a number line what would happen is I go and make my limit at -2, and then I'm going bigger than -2, so I'm going towards -1, 0, 1, can you see that, 2, and then because I work with integers, -2 is excluded, so I make an open dot. Because I work with integers, I'm going to make separate dots, I'm not going to make a line, so then I make a few separate dots. I think you need to make at least like 3. It's not really necessary to do more than that, but standard is do 3 dots. So I'm going to make dots to show that I'm working with integers, but then because it goes on, I must just also show this goes on, and what you do is you just put a little arrow on the last dot. My arrow is ugly. You just put a little arrow on the last dot to show that it continues. You can make the arrow here parallel to the dot, or I've also seen textbooks doing it like this. They take this and then they just make the arrow down like that to just show it continues in that direction with this pattern. So it means it continues like that, but it's integers, it's not real numbers. Right, so when it continues and it's real numbers, I just simply make my open or closed dot on the value, and I make a line of about 4 or 5 centimeters, and I make an arrow to show that it goes on. If it's infinite sets that continue but it's integers or natural numbers, then I will just make a few dots to show the integers and then make the arrow. Alright, so that is the different notations that you get, that you can identify and define number sets with.